Hey boys and girls. All right, let's do a little review for Unit 15. Hopefully all of this is not new to you. This is why it's a review. So if you've been going through all of the lessons and doing your Khan Academy, then you should have seen most of this already. But so here we go. A lot of different pages here. You can kind of think of these as being slides. But point, you need to know what a point is. And points are usually labeled with letters. So if you were to see a line with various points on that line, we usually show points with these dots, and we usually assign them a letter like M, N, O. These all could be different points on a line. Speaking of lines, should know what a line looks like. We usually look to the outside to tell us what we're looking at, and if we see these arrows on the outside, then we know that we're dealing with a line. So the arrows on the outside usually will tell you that you're looking at a line. Sometimes we might be looking at a line segment. The word segment usually means a piece. So when I look to the outside of the line and I see these points, or these dots here, that tells me that I'm looking at a line segment. That means that the line either starts there and ends there, or starts here and ends there. So I can also label this as, let's say, B and C. So this could be line segment BC, or CB, depending on how you want to look at it. You can also label it as CB, going in the opposite direction from here to here. Array will have a starting point. So you see the end point right there, or the starting point, and then it's showing you that it's moving down in this direction. And I drew a picture of a sun because we can think about, let's say, a ray of light starting from the sun and then moving in one direction, let's say heading towards Earth, like a ray of light. So this could be your starting point and then heading off in that direction. That's what a ray is. We use a couple of rays to make an angle. So you can see right here is the starting point, and we have one ray that goes off in this direction, and we have another ray that goes off in this direction. And then what we've created, since they share this common point, which is actually called a vertex, we'll get to that in a second, but this angle between this line and this line, there's an opening here, and we use angles to actually describe units of rotation. So as this thing is, I can move a line around a circle, and this right here is my angle. We're going to get to naming angles pretty soon, but before we do that, let's talk about the vertex, which is right there. This is where these two rays are kind of meeting right here at this point. So a vertex, you can remember the letter V. Vertex is where two lines or two rays or two line segments come together. So as I look at this word vertex, just remember that where they meet, that is the vertex right there. So even in this letter E, this line and this line meet right there, that would be a vertex. This line meets this line right here, it's another vertex. Here's another one. I'm not really calling this one a vertex because this is a curved line, so we need straight line segments here. So here, this could be considered a vertex here. Even right here in the T could be considered a vertex. In this letter E, there's a vertex there, right here, right there. And then even in this X right here, this could be considered the vertex. So as I look at this letter X, there's actually 4 angles in there. There's 1, 2, 3, 4 angles that are created, and they all share this common vertex. So there's different kinds of angles, and usually you can recognize them just by sight. But the acute angle is any angle that measures less than 90 degrees. We use the reminder, oh, look at that angle, it's so small, it's so cute. This is probably one of the most recognizable. A right angle 90 degrees, always 90 degrees, has a perfect square corner. If I look at this square, I can kind of put that right in there. And the corner right here, this has, the square has 4 90-degree angles. Anything that's larger than 90 degrees, meaning 91 degrees, all the way up to 179 degrees, is an obtuse angle. So the opening here, anything that's larger than 90 degrees, and you're moving into the obtuse category. All the way up to 179 degrees, because once you get to 180 degrees, that's what a straight angle is. And straight angles honestly just look like straight lines. But the opening from this side all the way around to this side would be 180 degrees. So these are some of the different types of categories of angles. It's also a reflex angle. Once you go beyond the 180 degrees, then we're going to talk reflex angle. So if this was a straight line here, once I open it up even more than 180 degrees, then we're talking a reflex angle. And I'm talking about this area here, not this area here. The angle that's made here could be considered an obtuse angle, because that's a little bit less, but it's this outside here, reflex. Just think, wow, I have to really flex or be really flexible to be able to bend with such a big opening there. Reflex angle. So what about naming angles? Angles are usually named, not usually, always. I can draw a point there, call this A. Draw my vertex right here, we'll call this B, and then we'll put another point out here, and we'll call this C. So when we name angles, vertex is always in the middle. So this letter B right here, that's always going to be in the middle. When I label it, usually they put a little symbol that looks like this is to represent an angle, and then they can call this angle A, B, C. Notice the vertex is in the middle because it's in the middle here. So the same thing when I label it. So that's just looking at it this way, angle A, B, C. But I can also label this as CBA, going this way from CBA. So I would label it as CBA. And always remember, as long as your vertex is in the middle, which it's right here, notice it's in the middle. It's in the middle again, depending on how you look at it. But that's how we name them, always with the vertex in the middle. So you can look at it as ABC or CBA. Doesn't matter. All right, as long as you have that vertex in the middle. Let's see. Sometimes you can see angles in 2D shapes. So as I look right here, I have a trapezoid. Doesn't matter how I move it, spin it around, doesn't matter. It's still a trapezoid. And you can notice there's angles here, 4 angles. So this angle here and this angle there, these look like acute angles to me, while the ones on the bottom here and here look like obtuse angles. You can see, if I were to just draw a line and a line, and right where they meet, if I were to pull that away, that looks like an obtuse angle to me, for sure. What about over here? Looks like we have obtuse angle on the top and the bottom, while we have acute angles over here and over here on the outsides, on the left and the right. Talking acute angles. And here we have a little mix. Definitely looks like a right angle right here. This could be considered a right angle, 90 degrees. And then I have 2 acute angles. I could leave it in the same position, but this could be considered an acute angle here. This is also an acute angle. So I have a right, an acute, an acute. Right. That brings us to finding unknown angles. So as I look on the outside of this angle here, this is definitely my right angle. It looks a lot like a square corner. My square corner right there. You can see the black lines on the top as well as the outside. So keeping that in mind, that the outside would be 90 degrees, meaning this green area plus this yellow area would equal 90 degrees. You can use that knowledge of a right angle to help you find an unknown angle. So if you know that this angle in yellow is 30 degrees, what would be the measure of this angle in green? Well, it would have to be 60, because the only way I could get the full 90, here's right here, 90 degrees, so it would be this yellow 30 plus this green would have to be 60. That's how I'm going to equal my 90 degrees, which would be the yellow and the green combined. You can look at the outside for that. Okay, so sometimes you don't need a protractor to necessarily measure an angle if you have a good understanding of what straight angles are and how much it is all the way around a circle. Let's say if you had a circle, you know that's 360 degrees all the way around, and you also have straight angles, which are 180 degrees. So using our knowledge of the 90, as well as a full rotation 360, and the straight line, which is 180, that knowledge will help you determine the measure of an unknown angle. We can try again using a straight angle. This is an example of the straight angle. Notice the straight line along here. So you know that this green plus this yellow would equal 180 degrees. So if they give you, let's say, the yellow area, which is 140 degrees, plus some unknown angle, which would here representing a green, has to equal the total of 180 degrees. It's, once again, your knowledge of a straight angle, the fact that it's 180 degrees can help you here. The only way that I could get to 180, if I already had 140 here, I have 140 here, if I were to add another 40 degrees, that would get me to my 180, so that would mean that this angle would have to equal 40 degrees. 140 plus the 40 will give you the entire 180 all the way around there. Okay? That brings us to unit angles. What I have here is a circle, and you'll notice that it's divided into 4 equal size pieces. Every one of these pieces is 1/4 of the circle. And they're unit angles. Unit angles are the same amount all the way around. So I have 4 angles that are the same amount. So if this is 90 degrees, well, that would mean that this has to be 90 degrees also. This is also 90 degrees. This is also 90 degrees. So you can think of, well, what is 1/4? Let's just say this yellow one, I labeled it as 90, but 1/4 of the total. This is a circle, and we remember that circle is 360 degrees, so 1/4 of 360 can be thought of as 1/4 times 360. And multiplying here, 360 can be turned into a fraction by simply putting a 1 underneath as a denominator. And when I multiply across the top, 1 times 360 would give me 360. And then multiplying across the bottom with my denominators, 4 times 1 would give me 4. And this is just a simple division problem. I want to get it right. Put the top number on the right, and we're going to divide by 4. And my knowledge of math facts, 4 goes into 360 90 times. 4 goes into 36 9 times, and 4 times 9 is 36. Next step, subtract. Next step, bring the 0 down. Does 4 go into 0? It will not, but I'll let you know with a 0. 0 times 4 would be 0. No remainder. So here it is right there. If it's 1/4 of 360, this right here, 1/4 of 360 has to be 90. It's 90 degrees. Unit angles again, only using straight line. This right here, I actually use this shape to help me. This triangle, if you look, it's pretty much right there. This line along with the bottom right there. So this is roughly 60 degrees. And I know that the orange area plus the yellow area plus the green area, they look like they're relatively the same. They're pretty much the same size. Again, I use this triangle to help me make these shapes. You can see it kind of fits in there. I don't really need to show you over there, but this is 60. 60 plus 60 plus 60 would give me 180. So these are unit angles because they're all the same size. Could have also taken one of the 60s. And how many are there? Well, there's 1, 2, 3 of them. So if they're all the same, I can multiply, equal groups. 3 times 0 is 0. 3 times 6, 18. So that would give you this, plus this, plus this. All of this, all 3 together, would equal your 180 degrees. But these are unit angles because they're all the same. Okay? So hopefully that helps. Ideally, you're not looking at any of this for the first time because this is a review. All right? Good luck on your test. Hope this helps. See you next time.